This is page 2 of the Chapter 9 notes, and I'll look at the non-answer key version first. Let's see how this is a hypothesis test as well. The mean work week for engineers in a startup company is believed to be about 60 hours. So that is our null hypothesis. When I see that, I see the word mean. And so the null hypothesis is mu equals 60. A newly hired engineer hopes that it's shorter. She asks 10 engineering friends for the lengths of their work weeks based on the results that follow. And assuming that hours worked per week are normally distributed, should she count on the mean work week to be shorter than 60 hours? That would be our alternate hypothesis. Mu is lower than 60. The responses she collected, so these are 10 data values, and we're going to need n and x bar and s, which we're going to get from the data. So these we are going to calculate from the data, and then we'll determine if there's enough evidence to suggest that the work week is less than 60 hours. Again, like before, I suggest that you go through and label what everything is. That's our alpha value. And if we can put all of this data into the calculator here, then we can get n, which is 10. We already know that. X bar and s we will get from the data values. And I am going to briefly point out that n equals 10 isn't big enough, but we have a normal distribution that we're drawing from, so that's what allows us to get away with just using a sample size of 10. If our underlying distribution isn't normal, then we have to get 30 or more data values. So to put the data in my calculator, I'll go stat edit, and I already typed it all in L1. I'm just going to remind you that if you have data in here, you can arrow up, clear, and arrow down to make the data go away. You have to put your cursor on top of the name of the list first. If I just press clear here, it doesn't really work. So clear, enter. I think it just gets confused and leaves the data there. So clear, and now I've cleared all the data out, and I have the 10 values of data in here in L1. Second quit, stat, calc, one variable stats, L1, frequency list. I think I can leave it empty, or maybe I have to put something there. Sometimes I put a 1 there, and sometimes I leave it blank. Let's see if this works. Okay, this seems fine. So X bar is 57, and S is 7.15. X bar is 57, and S is 7.15. And what is mu? Well, that's the mu from the null hypothesis, so 60. And my degrees of freedom is n minus 1. Why are we talking about degrees of freedom? We talk about degrees of freedom when we're using a t-distribution. And when do we use a t-distribution? We use a t-distribution when we do not know the population standard deviation. Sigma, the population standard deviation, was not given in this problem. One thing that's a little confusing is that your calculator is acting like it knows what sigma is, but it actually doesn't. All we are working from is a sample, so we have our S, we do not have sigma. If you would have the population standard deviation, then it would be given to you explicitly in the problem itself. So because it wasn't given, we are using a t-distribution. And with a t-distribution, we need to know the degrees of freedom, and that is 9. Okay, so we've filled out everything that we know here. We calculated the sample mean, and it is lower than 60. It's 57. Are we done? I've had students who are just like, yep, the sample mean is below 60, so we're done. But the truth is that there is variability in sampling, so this does not necessarily prove that the population mean is lower than 60. We need to go through the hypothesis testing process. So in my answer key, I wrote this out in a little bit more detail. Let's take a look at that. Even if the population mean mu is 60, it is possible to get x bar equals 57. We need to find out if x bar equals 57 is slightly weird or super weird. So that's where we start to draw the t-distribution and decide if the area P is smaller than alpha or not. So the nice thing is, I'm not going to sit down and write this, but you should copy what I wrote on the answer key or put it into your own words. Here is our t-distribution, and I've drawn 3 different t-distributions, but this is the one that we're actually working with. When you have the degrees of freedom equals infinity, you have the normal distribution. df equals 1 is a little bit wider spread out, and that's what I said before. So we're going to perform the t-test and then write down the value of t that we get. So we're going to go to stat, test, t-test, enter. And this time we're working from actual data. So we select data. Our mu0 is 60. Our data is in L1. The frequency is 1. I'll just leave that. And the alternate hypothesis is that mu is less than mu0, so we do need to indicate that. And then I would like to have the calculator draw the t-distribution. For those of you who only have a TI-83, I believe you don't have this as an option. Okay, so the t-score that we get is negative 1.327. So that would be right about here. Let me try that again. That's a little bit better. Negative 1.327 is where I am, and I'm shading underneath the df equals 9 line. So I'll try to shade, I mean, this screen on the calculator does a better job, but I'll give it a shot. That's what I'm shading right there. Shade the area to the left of it, so that is my area P. We need to find the area P, and here I'm saying it's 0.1086. There is the area P on your calculator, 0.1086. We could find this using the TCDF thing on the calculator, or we can just be happy with what we've got. Oh, we already did the drawing thing, so we're all set with that. So the area to the left of t equals 1.3270 is this area. So if the null hypothesis is true, the odds of getting a sample mean of 57 is about 11%. Now that area P is bigger than alpha. We are going to fail to reject the null hypothesis. It wasn't weird enough. We needed to get an area P that was smaller than 0.05, and we didn't. So we're not as suspicious as we need to be to reject the null hypothesis. Therefore, we fail to reject the null hypothesis. There is not enough evidence to suggest that, and then we go and look at HA again and write it in the context of the situation. So our alternate hypothesis, here it is, was mu is less than 60. And remember that what we're talking about here is the mean, the population mean hours of work in a week. The length of the work week in hours for the entire population. We did not have enough evidence to suggest that the population mean hours worked per week is lower than 60. There was not enough evidence to suggest that. And that's how I want you to write your conclusion. Put HA in the context of the situation. So really HA was just mu less than 60, so you're wording it in real life language. The last thing I wanted you to do for this problem is to confirm that p-value using TCDF. Again, because the TI-83 can't do this, I am not likely to put this on the test itself. So you might need to understand that we're using the t-distribution and why, but I won't be actually asking you to do this. Second distribution, TCDF. Lower is -1 E99, comma, -1.3270. And then we just have to give the degrees of freedom, close parentheses. And that is our area P. So we did confirm that that equals 0.1086 if you round it.